The good news is there's lots of software out there that can use the real regular expressions, including Notepad++, which we just saw in the workshop. Okay. Let's have a look at a few addresses. Yeah, imagine we've got a company. Is it? Can I zoom? Yeah. Can you read it like this? No. So imagine we have a company, and we ask our employees to write down the name, the addresses of our customers, and that's what they came up with. Yeah. Do you see any problems here?
Abbreviations and non-abbreviations.
Yeah. So let's say we got CL. What's that? Close. DR. Live. Then we got RD with and without a dot. We got street, we got ST, we got ST dot, we got STR dot, we got all sorts of situations. Yeah. If we want to fix that, how can we do that? Again, old-fashioned approach without regular expressions. I got to now go and find all the different abbreviations for street, and then I find abbreviation 1 for street, replace it with street. I find abbreviation 2 for street. Yeah. I replace all the STs with street. I replace all the ST dots with street. I replace all the STRs with street, and so on. But actually, there are much easier ways. Again, regular expressions to the rescue. Okay, let's open our web browser. There are lots of nice web pages. Like X101 is a good one. Oh, yeah. By the way, here this is the official Microsoft page where they talk about regular expressions. They call it regular expressions, but like I said, at least in Word, it's not what the rest of the world calls regular expressions. But with a bit of luck down the line, because they are a much nicer company now than they used to be. With a bit of luck down the line, they'll probably fix that. Okay. Yeah. How do regular expressions work? I've got some sort of test string, that's where I run my queries on, and I want to look for something. Yeah. So let's say I want to look for the letter E. I just type E. Yeah, it finds me all the occurrences of the letter E. That's pretty straightforward. Yeah. It's like if you click on search or find in Word or anywhere else, you look for E, you got all the E's. You look for VI, you got all the VI's. And so on. Wait, I'll try to zoom in a bit more, then maybe it's easier to see. Okay, can you see well like this? Yeah. Okay, the good thing is now we can let's think of an example. Okay. Yeah. Let's make something else up. Cat and hat. Oh, hat, yeah. And that. Yeah. Okay, I type. I want to find everything with AT. What do I type?
That's it.
AT, yeah. Well done. Yeah, and we got it here. Now let's say I only want to find cat and hat, and I don't want to find that. I use the square brackets, and then I give the system everything that should be included in my selection. So I want everything with a C or an H. Yeah. Now it shows me everything that is a C or an H, followed by a T. Yeah. Yeah. In this case, can you see it in the back? Can you see it, or is it too small?
No, I can see it.
Yeah. It's okay.
Yeah.
Yeah. So. Yeah, now it found cat and hat, it didn't found that, because I said I want everything that starts with a C or an H, followed by a T. Yeah. And I put, on this handout, I put this cheat sheet that has lots of those rules. So squarely brackets, that's a quite important rule. Everything you put in squarely brackets is basically one of the allowed options. Okay, let's look at that word Emmanuel drive. Maybe, I don't know, maybe I know there's a mistake in my database. Sometimes it's spelled with one M, but it should be spelled with two M's. Or I want to find it independent of the spelling. What can I do? If you look on the cheat sheet, in the middle there's a section called quantifiers. So star means 0 or more, plus means 1 or more, and question mark means 0 or 1. So I want Emmanuel with 1 or with 2 M's. Yeah, I could write EM plus annual. Yeah. So what does plus mean?
No more.
Hmm?
One more.
1 or more, yeah. So, and it applies to the previous character. So I'm basically saying an E followed by 1 or more M's followed by annual. Yeah, would it work with a star? Star is 0 or more? Yeah. Yeah, all right. Yeah, also works. We also got 0 or 1. So another way of doing the same thing would be I definitely want an M. And then I want another M, but we don't need to use the other M. Yeah. It's another way of doing it. So there will be many ways of achieving what we want to achieve. But the there's a difference. In this case now it only catches 1 or 2 M's. Our first example, I even would have caught 3 or 4 M's. I can do curly brackets. Yeah. Then basically I say how many do I want to catch, and I can say I want to catch 1 or 2. Yeah. Why does it not pick it up?
Because you got rid of the A.
Ah, the A is missing. Clever, thank you. I just thought, oh, why does it not work? The A is missing. Yeah, good. Good for spotting it. Who said it? Bonus points. Ah, actually, I have some books in my office that I wanted to bring. I thought, oh, I'll hand some out. It could have been a bonus point. Yeah, so it didn't catch it because the A was missing. Come to my office if you want a free book. Let's relate it to the module. Okay. Yeah, so there are many ways of constructing the whole thing. So let's say we want to fix street. Yeah. So what different abbreviations do we have for street? So somebody read out the first one?
ST.
ST, okay. ST. Another one?
ST dot.
ST dot, okay. Now the problem is, the dot has a specific meaning. And if we look on the cheat sheet, a dot means any character except new line. Yeah. So, let's look at an example. Chatburn house. Yeah. Chatburn. If I type it, I get a hit. And if I type ch dot, you see the dot matches any possible character. Chatburn. Yeah. Think of Gray. There's the American and the English spelling. Yeah, I want to have both. I can type this. Okay. So how can we distinguish between a dot that means any symbol and a dot that actually means a dot? Now that's the same in any computer context usually. What we do is we escape the character, and escaping the character just means we put a backslash in front of the character. So putting a backslash in front of any symbol that has a different meaning gets rid of that special meaning. Yeah. So ST dot, yeah, doesn't match ST dot. ST dot matches ST followed by anything. That's why it also matches STR. Yeah. But now we don't want that special meaning for the dot, which means any symbol. We want actually to look for the dot. So the moment we want to do something like that, we put a backslash in front. Yeah. And now it only matches ST dot, not STR. What other special characters have we seen just before? I showed you a few earlier that have a special meaning.
Plus.
Plus, yeah. So if I use a plus, it has a special meaning. But if I want the symbol plus in my text, I just put a backslash first, and that will look for the plus instead of giving plus the special meaning. Okay, now we got ST backslash dot. Yeah. What other abbreviations are there for street? Or let's look at something else. The problem now is, now we don't catch ST anymore, because now we say there should be a dot. So this is a problem now, because even now we capture the ST dot abbreviation, we don't capture ST anymore. So now we want to tell the system, ignore the dot. We ignore the dot if you want. Kind of. There could be a dot, there could not be a dot. So have a look at the cheat sheet and try to think what we could find. We want to tell the system there is a dot, but it doesn't have to be there.
Put the asterisk after.
Second?
Put the asterisk at the start.
The asterisk?
After the forward slash.
Okay, yeah. If we do the asterisk, we basically say we could have no dot, we could have one dot, we could have two dots, we could have 4 million dots. Yeah. Yeah. So it does work in our case. I put a star. You meant the star when you said asterisk. Yeah. I put the star, the asterisk there, and it does what we want. And there will be other solutions. Yeah, another solution would be the question mark. It would work in our case, because in our case, there are dots or no dots. The difference is, if there are many dots, the two regular expressions would catch different amounts of cases. But in our case, it's kind of the same thing. Okay, what other abbreviations are there? We're nearly there.
STR.
STR. So how do I need to change my regular expression to catch STR as well?
STR question mark / dot question mark.
STR. Okay, now we only capture STR. Now I put a question mark. Yeah, exactly right. Yeah. Now we capture everything starting with ST. Then there can be an R. There doesn't have to be an R. And there can be a dot. There doesn't have to be a dot. Now I caught all the different abbreviations for street, and I can just use find the place. I give it that kind of text, and I just say the place with street. I hope you find it useful. I think it's quite useful. Imagine they typed street wrong. Let's say they typed, some of our employees might have typed it with lowercase s. Now we don't catch it anymore. So how can I change my regular expression to also capture cases where the s could be lowercase?
Square brackets.
Yeah, exactly. That's the first thing I said. Square brackets. You're doing all the hard work yourself, you poor guy. Okay, what do I put in the square brackets?
Alpha colon.
So I put this lowercase and the uppercase into the square brackets, yeah? Think about the example with cat and hat. I did square brackets ch, square brackets at. Yeah. So here I'm saying lowercase s or uppercase s followed by t, followed by an r or no r, followed by a dot or no dot. Look, and here we get a nice explanation how it works. Look here, SS matches a single character in the list s uppercase, s lowercase. Which way round I do, it doesn't matter. T matches the character T literally. R matches the character R literally between 0 and 1 time. / dot question mark matches the character dot literally between 0 and 1 time. Okay, let's open Notepad++. Oh, I already put it there. So let's copy the regular expression we made. Place. And replace it with street. Yeah, replace all. Oops. Mistake. It also replaced now the beginning of street. So it replaced the str in street with street. So we have street from the replacement in EET. So how do we fix that? tell me in English language what when we want to find this case. Yeah, we want to find it if it's an abbreviation. It doesn't apply here. Why does it not apply here? Just tell me in plain English, and then I'll try to turn your plain English into a computer rule.
It's not an abbreviation. Because it's not an abbreviation, it's the full word itself.
It's not
But how do you know?
It's not followed by an E. Another letter.
Yeah, okay. So we can basically say we only want it if it's at the end of some sort of word, if it's at the end of some sort of sequence. Is it on your cheat sheet? I hope it is. Here, the word boundary. Left column, 1, 2, 3, 4, 5. The fifth from the top, word boundary. So we only want it if it's at the end of a, if there's a word boundary afterwards. Yeah. A word boundary is if there's a space before or after, or if there's a return after, or anything like that. Could also be a quote or something like that, a quote mark. So now I'm basically saying, and I want the whole thing, and I only want it if it's followed by a word boundary. So now we don't get a hit for a sleet anymore. And if I run the placement now, it would not mess up sleet anymore. Yeah. So we can always make it a bit more complex to do a little bit more. The problem is now, when you look at this, it's getting pretty messy. But one by one, if you look at the rules, it all applies, it all makes sense. One thing I find confusing with regular expressions is that the same character can mean very different things, depending on the context. For example, the question mark. And something else that's quite important, and that will be the first step if you work with regular expressions, is that the regular expressions are greedy by default. That means they try to match as much as possible. So let's say, let's find an example. Let's say I say B followed by any character, and however many characters I want. And an E. Yeah. So regular expressions are greedy. They could have stopped after this E. Yeah, but instead of stopping after the first occasion, they try to capture as much as possible by default. And if you don't want that behavior, instead of capturing as much as possible, you want to capture as few as possible, you can make it lazy. And that should be somewhere in your cheat sheet. If not, you can write it down. It's the question mark. I don't see it. If you put a question mark after a quantifier, you make, oh, it's here. They just call it ungreedy instead of lazy, but it's the same thing. If you look in the middle column under quantifiers, add a question mark to a quantifier to make it ungreedy. The problem here is the question mark can mean many different things. You see, in this case, the question mark means you want it to behave lazy. In another case, if it's not preceded by a quantifier, if it's preceded by a literal, for example, then it means 0 or 1. So the same symbol can mean different things. Yeah. Okay, real world scenario, BU1106. I want to leave this page. Did anybody work on our KMS today? No. Okay, let's say I want an article about GitHub. And as, as we discussed often in the past, look here, we use the same license as Wikipedia. Yeah? So theoretically, I could just go to Wikipedia and I can just copy. Yeah. I could just copy everything. Yeah. And paste it here. Good. Yeah. To comply with the rules of the license, I'd have to link back to this version so that the contributors are acknowledged. I could do that in the comment box. But if I just copy this, look, there'll be lots of links. Access control, bug tracking, feature request. And there are links I might never want to add to our KMS because that's out of the scope of our KMS. I could use my regular expressions to, for example, get rid of all the links. Yeah. So I could say I want to find everything that's a link. Yeah. So look, now it finds all the link, all the opening double square brackets. Now, yeah, followed by something, followed by closing brackets. Yeah. And because it's greedy, it found too much, so I'll make it lazy. Yeah, that already looks better. I want to replace this with what's in the brackets. I make a capture group. That's what I showed you in Microsoft Word. So I make a capture group by opening round brackets. And now everything in those basically round brackets is my first group. So if I want to replace this with what's in the round brackets, I just write \1 for the first capture group. If I've got 2, I write \2. So that would already get rid of all those links. The problem is, look, sometimes in Wikipedia, I've got a difference between the link and the text being displayed. The text says, in July 2015, GitHub raised another $250 million of venture capital in a Series B round. So the text in the sentence is Series B round, but it links to a wiki page called Series B. So I only want to capture what's after the pipe. This vertical line is called a pipe. How can I do that? So I've got square brackets. So if we've got a difference between a link text and a link, how does it look like? We've got the name of the link, we've got the pipe symbol, and we've got the name in the text. So now instead of capturing the text in the square brackets, I want to capture the text after the pipe. How do I do that? Okay, let's look at this example. Any ideas? I only want to capture this bit, series B round. So I want to capture the text after. Okay, what's the first letter I want to capture? S, okay. So I could go with lowercase s, it would work in this case, but I wanted to work in any case. In another case, if it could be called, I don't know, Britain, and then here it actually links to Great Britain or something like that. So what's the important thing with that S? Is it after or before a symbol? Is that how we could find it?
After a pipe space.
After a pipe, yeah. So, and before the pipe there's also stuff. Yeah. We are a bit closer now. Now we only capture series B round. The problem at the moment is we captured the opening square brackets here, and it then just kept going. Yeah, we're at the end already for today. So think about it, and for next workshop there'll be some regular expression tasks waiting for you in GitHub.
You might go on after an hour. Yeah, just might go on after an hour. It might as well hit you in that smack. Like that guy, he's kind of there after an hour. He's an engineering student and he designs work in mountains after an hour. Yeah.
I would not want to get in that area. Not even probably like